All right, so we're looking at acute angles of a right triangle are complementary. So we are given that we have a right triangle as shown, and we want to prove that angle A and angle C are complementary. So our first statement and reason is just the given. If we look at our second statement that angle B is a right angle, then our reason for that is going to be that that is a definition of a right triangle. From that, then, we would need to know that if angle B is a right angle, that the measure of angle B is equal to 90, and that is just our definition of a right angle. Looking at what's next, it says that the measure of angle A plus the measure of angle C plus the measure of angle B is 180 degrees, and that is our triangle sum theorem that we just went through on part 1 of the notes. So if we look at statements C and D, we're going to take and say, well, if we have the measure of angle A plus the measure of angle C, and then what we're going to do is take this measure of angle B and substitute in 90. That's going to equal 180, and that was by substitution. Now, if we were going to take and we wanted to move that 90 over to the other side just by subtraction, what would happen is that we would have that the measure of angle A plus the measure of angle C is going to be equal to 90 degrees. And then that tells me that angle A and angle C are complementary, because that is the definition of complementary, and proves our statement that angle A and angle C are complementary. Now there's a couple of things at the bottom of the page we want to go through that I have filled in already for you. So there can be at most one right angle or one obtuse angle in a triangle. So let's talk about right angles first. We know that triangle ABC, that the measure of angle A plus the measure of angle C plus the measure of angle B is 180 degrees. That's our triangle sum theorem. If angle A is a right angle and angle C is a right angle, and we add B to it, then that has to be greater than 180 degrees. Thus, it's not possible to have more than one right angle in a triangle. If we talk about obtuse angles, if we can't have two right angles, we can't have two obtuse angles, because that would make the triangle sum more than 180 degrees. All right, so let's look at our isosceles triangle theorem. This is from section 4.6. The next following things will all be from section 4.6. So if we look at this, it says if a triangle has two congruent sides, then the angles across from the congruent sides are congruent. So therefore, in symbols, if we have a triangle with two congruent sides, then that implies that in that triangle, the angles across from those congruent sides are congruent. So what would that mean for triangle WET over here? That would mean that angle W would have to be congruent to angle T. If a triangle has two congruent sides, this is our converse triangle theorem. If a triangle has two congruent sides, then the sides across from the congruent angles are congruent. So basically in symbols, we're saying if we have two congruent angles, then the sides across from those are congruent. So what does this say? What should be true then for triangle SAD? That would tell us that we would look at SA and that would be congruent to SD. If we go further, we have a equilateral equal angular triangle theorem that says that every equilateral triangle is equal angular. So if all three sides are equilateral, then all three angles are equal angular. And then every equal angular triangle is equilateral.